In this video, we would like to present some vocabularies or models that allow to represent the information in traditional language resources in semantic web formats. We will start by mentioning SCOS and SCOS-XL. In short, we can say SCOS is a vocabulary to represent thesauri in the semantic web. Then we will briefly mention LingInfo, LexOnto, and LIR, the Linguistic Information Repository, models that emerge from the need of enriching, documenting ontologies with linguistic and terminological information. And finally, we will focus on Lemon, and specifically Lemon OntoLex, which in a way bring the three previous models together, and which can be defined as models for representing linguistic descriptions relative to ontologies or as self-contained RDF resources. So why do they emerge? Well, we can claim that all these models emerge from the need of providing more principled descriptions in natural language of ontology entities, be they ontology classes or properties, or concepts or properties. And what does this mean in practical terms? Well, it means that the most popular ontology languages, RDFS, OWL, rely on RDFS properties, being the most popular one, RDFS label, as we can see in the slide, for providing natural language descriptions of ontology entities. And this is basically the mechanism that RDFS and OWL provide for documenting, describing ontology entities in natural language. You'll agree with me, it is not enough, it's quite limited. This language is also resort to RDFS Common for definitions or explanations and other Dublin Core metadata such as provenance, source, as can be seen in this snapshot from an ontology of the hydrology domain built in Protege. So all these properties permit to associate natural language descriptions to ontology entities as literals. And this fact, the fact that these are properties and not classes, imposes important restrictions, such as that one cannot make assertions about them. This means we cannot say anything about these descriptions. For example, we cannot further say that a certain word or term describing an ontology entity is a noun or a verb or an adjective, which could be very interesting for NLP tasks. We cannot state that one term is the acronym or the abbreviated form of another term. We cannot establish relations between these several descriptions. Here in this case, we cannot say that Riva is the translation of Rio in Spanish and so on. So in the end, this means that attaching description to ontology entities in this way results in a bunch of unrelated data whose motivation is difficult to understand even for a human user, or at least it has to be interpreted by a human user. So mainly as a result of this limitation, other vocabularies appeared, such as SCOS. SCOS stands for Simple Knowledge Organization System, or its evolution, SCOS-XL. And these are models for expressing the basic structure and content of concept schemas, such as thesauri. We have seen some examples in the previous video. Classification schemas, taxonomies, and other similar types of control vocabularies. Here we have some relations to establish relations between concepts, and these are broader than, narrower than, and related to. And then at word level, or at term level, one can distinguish between preferred label, alternative label, and hidden label. And these different types of labels can be attached or associated to one and the same concept. But at the end of the day, SCOS labels inherit the same problems that RDFS labels had. They are properties that describe ontology entities, and no further assertions can be done about them. So conscious of this problem, SCOS people initially or partially solved this problem with SCOS-XL, an evolution of SCOS that introduces the class SCOS label, SCOS-XL label, and considers labels first-class citizens so that we can now make assertions about those classes, about those labels. But in the end, this did not provide a principled solution for the problem either. So SCOS-XL is not offering a set of classes modeled or structured in a principled way for linguistic information in general. So as a result, other models appeared as the ones you can see on the slide. The main purpose of these models was to provide a set of linguistic descriptions for lexicalizing, for documenting in a principled manner existing conceptualizations or ontologies, or to put it in other words, for complementing or enriching existing conceptualizations with linguistic information. LincInfo was the first model of this kind and focused on the representation of terms for describing ontology classes and properties, accounting for their inflection and morphological decomposition. Lexonto was born with the purpose of capturing the syntactic behavior of words or terms in relation to their counterparts in the ontological representation. And LIR's main objective was to represent the relation between the terms lexicalizing ontology classes and properties, that is, term variants, as well as terms in several languages, that is, translations. So, what has been the evolution? Well, all these models that had similar aims were merged into Lemon and its subsequent evolution, Lemon Ontolex, that I will explain in a minute. Lemon consists of a core, a set of classes that I'll show in a module, and several modules. Basically, the main features of Lemon are summarized in this slide. The semantics are captured in the ontology, and the lexical and terminological descriptions of all these ontologies entities are captured in a separate module, in a lexicon model, in a Lemon model. Lemon is a concise and descriptive model in its design, in the sense that it uses external sources for the majority of its definitions, and also a modular and extensible, in the sense that it can be extended in different ways to handle different purposes. So if we are interested in representing terminological variation, we'll use a certain module. If we want to represent morphosyntactic descriptions, we'll go for another module, etc. It is worth mentioning that Lemon is implemented in RDF as an ontology in itself. So now, this model also allows to transform language resources into ontologies, so to say. So for more details on this model, we recommend that you go to the following address. Afterwards, Lemon was open to the community, seeing that it was adopted more and more by the community. So it was open under the framework of the W3C, the standardization body, and here we have the result, Lemon Ontolex. There were many discussions about which linguistic classes should be included, which ones should remain, which ones should be left out, how the linguistic information should be organized and structured into how many modules, etc. And finally, it was released in May 2016. The final community report was released, as I said, in May, and here you have the link, and for the sake of illustration, in order to give you a hint of, or a glimpse of the model, we'll focus on the core classes of the model in the next slide. So here you see the Lemon Ontolex core. You see a set of classes that the central one is the lexical entry. So lexical entry is the lexical representation or the natural language description of the ontology entity in question. That's kind of the central class, yeah? And a lexical, as you can see there, the lexical entry can be either a single word, a term, or a multi-word expression, or even or even a prefix, a suffix, etc. A lexical entry has a form, which can be a written form, written representation, or phonetic representation. And then it also points to the ontology entity in question through the lexical sense class. In the lexical sense class, we specify pragmatic aspects of the use of the word, for example, if it is a colloquial word or a scientific term, among other usage aspects. Then we have lexical concept that tries to capture or represent the concept or unit of thought represented by several lexical senses and lexical entries. And finally, we can also state that a set of lexical entries in the same language will belong to the same lexicon, and that would be the lexicon of a certain language, lexicon Spanish or English. And in the same way, a lexicon of concepts can be created by means of the concept set class. Let me show you an example. In this slide, you see how a certain concept in the ontology has been lexicalized, and it has two different lexical entries, autor, autores, in singular, in plural, so all these linguistic or lexical data can be expressed, represented, and structured in order to complement or enrich the ontological representation. And as I said, there are dedicated modules for representing translations, term variants, morphosyntactic information, syntactic structure, etc. So I encourage you to have a look at it and if you are interested in this topic.